Okay, in this video, we are going to see what happens to Km and Vmax in an uncompetitive inhibition. So, in my previous video, we discussed about how Km is inversely proportional to the affinity of the substrate towards the enzyme, right? Okay, now this information is going to help us determine answer for this question. Okay, so now let's directly come to uncompetitive inhibition. What happens in an uncompetitive inhibition? So let's write the general equation. Enzyme plus substrate, it gives rise to enzyme substrate complex, it gives rise to enzyme plus product. Okay, that's fine. Now there are two things about the inhibitor in case of uncompetitive inhibition. First thing is the inhibitor binds with the enzyme irreversibly. Okay, and the second thing is the inhibitor is having more affinity for the enzyme substrate than with the individual enzyme. Okay, so from this information, what you can tell about the Vmax? So the binding is irreversible, right? Enzyme is binding with the inhibitor irreversibly, which means once the inhibitor binds to the enzyme is non-functional and it is lost, right? So ET, the total enzyme, is going to go down, right? So what is going to happen with the Vmax? So Vmax is also going down, right? Okay, so when when total enzyme goes down, then Vmax also goes down. Okay, for explaining this, let me give an example. Let us suppose in the beginning, before adding the inhibitor, there were 100 units of this enzyme. Okay, then you added 50 units of this inhibitor. Okay, now let us suppose this 50 units of this inhibitors bind with 100 units of these enzymes. So if they bind with 100 units of these enzymes, what is going to happen is they are going to make these enzymes non-functional because the binding is irreversible, right? So there are only remaining 50 units of the enzymes, right? So what do you think will happen to the Vmax? The Vmax is definitely going to drop down. Okay, now you tell me what is going to happen to the Km. So Km depends upon the affinity of the substrate towards the enzyme, right? If affinity is more, Km is less. If affinity is less, Km is more, right? Okay. So in this situation, what is happening? So the inhibitor has more affinity towards the enzyme substrate complex than towards individual enzyme, right? So whenever we are introducing, let us suppose this is the system. Okay, it is having enzymes, it is having substrates. Okay, so when you are introducing this uncompetitive inhibitor in the system, what is going to happen is It is going to promote the formation of enzyme substrate complex, because the inhibitor is having more affinity for binding with the enzyme substrate complex than with individual. So in a way, it is increasing the affinity of the substrate towards the enzyme, right? So in a way, it is increasing the affinity of the substrate towards the enzyme. So what is going to happen to the Km? Km has to go down, right? So, so what is the answer to our question? In an uncompetitive inhibition, Vmax drops down and Km also drops down. So that's the answer for this question. Okay, so that's it. Let's meet in the next video.